Welcome to Swell Academy today, looking at one-step equations. We talked about one-step equations with addition, subtraction, multiplication, division. Now we're introducing same concept, inverse operations. We continue to look at that, but now just kind of with fractions. Now what I want to do is just kind of get a quick kind of review of what's going to happen with fractions. So basically you're going to end up doing some level of adding and subtracting of fractions. And I want to remind you that when adding fractions, we're looking for a common denominator. What that means is we're trying to get the fractions to be the same size pieces. We're trying to work with the same, so basically exchanging $5 bills or $10 bills, trying to make it the same size. Now what we do is we take our multiples of 2, 2, 4, 6, the 2 will go in 3 times, the 3 will go in twice, and that's how we're going to change our both top and bottom of the fraction. Our 1/2 now becomes, well, if 2 went into 6 3 times, then we're just going to do 3 times 1, and we're going to get that 3 out of 6. And nothing changes. The value stays the same. It's just you're changing the way it looks. Plus 3 goes into 6 twice, so 2 times 2, that's the 4/6 with the 7/6. Now, if you have a number on top that's bigger than a number on the bottom, you have a whole piece, so we'll represent that as a whole piece, and then left over with the 1/6. Now, if you understand this and you have this, and from previous videos this has worked, go ahead and fast forward to some of the examples of where I'm including a variable letter. But if you just want to get a quick, just kind of review, just stick around. Let's say you get a 1/2 minus. I definitely wanted to introduce this. We're going to change, obviously, the denominator to 4, 6, 8, 10. And you have your 5 and 10. Here's a match with the 10. 2 goes into 10 5 times. So 5 times 1, 5. But I like introducing this because what happens is you're subtracting a bigger number from a smaller number. So this is where I want to introduce you to students, this idea of a negative fraction. Basically, you have a number in which you've crossed over. Here you're at your 5/10, and you're subtracting. If you crossed over into the negative zone, here's the 0, the negative zone. You end up with that -3/10 because you've subtracted a total of 8, and that's something you have to keep in mind when you're working with these fractions. So let's take a look. Let's take a look at a couple examples here. For instance, let's take a look just simply, same numbers that we've used. Here's the 4/5 equal to the 1/2. So just like we did previously, okay, you want to get x by itself, so opposite operations, just subtracting 4/5 from both sides, okay? And this allows you to get x by itself because you've removed this from one side of the equation and you've moved it over to the other. Now, on the previous page, we did basically 1/2 minus the 4/5, remember? And that's where we got the 5/10 minus, we've got like denominators, minus the 8/10, and that's where we got the -3/10. And basically what we've identified is that x is equal to -3/10. And if we checked our work and did -3/10 plus 4/5, we would in fact end up with that 1/2 if you were to check your work. Now, let's say we were looking at a problem where instead of adding, you're now subtracting, and you have that -2/3 equal to 1/2. And then we're adding the 2/3 to both sides. This is very much like that, again, that example I showed you where we, on the previous page, where we added the 1/2 and 2/3, and we changed it to a 3/6 plus the 4/6, and we got the 7/6 here. This is just your typical one-step adding, subtracting fractions. You could get an example where it has x plus 5 1/2 is equal to maybe 3 1/3. Best way you can handle this, or be able to do this is actually just change these into improper fractions and make it an x plus 2 times 5, 10, plus 1, 11 over 2 equals 3 times 3, 9, plus 1, 10 over 3. And just take this, subtract, here's your fractions, find your like denominators, and solve. This is a good way to make it easier for you to kind of work with the fractions. Now, you could get one-step equations where you have the multiplication and division involved. So I want to just, again, like we did before, is kind of talk about what is multiplying fractions. What are some of the things we need to know about that? Well, one thing you want to look at is this idea of when you're multiplying fractions, this kind of cross-reducing, what I like to say, diagonally. So you have the 5 and 10. If we had 5 over 10, we would reduce that to 1/2. So some say canceling out, and that's basically what you're doing. The 5 becomes a 1, the 10 becomes a 2. And if you looked at 4 over 12, the same thing would happen where you would reduce this to 1/3, and that's where we cancel out the 12 to a 3, cancel out the 4 to 1. And then multiplying, just simply multiplying these numbers across, that's a multiplication symbol there, multiplying these numbers across, and you end up with 2 over 3. And basically I'm showing you that because if you're given a problem or a one-step equation where you have the, let's say 12 over 10x, you have this number next to x is equal to 4/5, okay? And again, we want to get x by itself, so we want to do inverse operations. What you could do as an inverse operation for this 12 over 10, to move it to the other side, is just basically multiply by its inverse. And if you look diagonally, these all cancel out to 1, and that's where you're left with 1. That's where you're left with x. And then what you do to one side, you're going to do to the other. And just like I showed you, you're cross-reducing like I showed you here, and you end up with that 2 over thirds. One thing I like to show too is that example where you end up with a 2/3 x is equal to 9, and your inverse operations, multiplying both sides by 3 over 2, write this as a 3, okay, and then you're like, well, what am I doing here? This is a whole number, this is a fraction. Well, okay, no, you're just simply putting this number over 1 and getting a 27 over 2. Now changing this to a mixed number is basically the idea of you're dividing 27 by 2, and 2 goes into 27 13 times with 1 left over, and that remainder is what you're putting over your denominator, that 13 and 1/2 here. And that's really all you're doing when you're working with fractions, multiplying, dividing, trying to get x by itself. Again, if you're given special case, you're given maybe a mixed number, 5 and 1/2 x is equal to a number, just simply make this an 11 over 2x is equal to 10. And this, making this an improper fraction, the 2 times 5 plus 1, doing that will make it easier for you to kind of, get this, cancel this out, multiply both sides by 2 over. More failure. I like to say, the more you fail, the more you succeed. That's it. You have to try things. You have to attempt it. If it doesn't work, go back, look at your mistakes. And I don't know if that makes sense. More failure equals more succeed. Probably more success, right? Because the more questions you get wrong, the more, as long as you go back and look at them, the more you're going to learn from. And so good luck. Keep working hard.